Okay, let's be honest. Does your code sometimes look like a tangled mess of repetition? If so, you're in exactly the right place. Today, we're going to unravel that mess. We're going to transform it into something clean, elegant, and seriously powerful, all by using one of Python's most essential tools, the function.
Just take a look at this. On the left, that's what I call the hard way. You've got the same chunk of code for calculating BMI copied and pasted over and over again. Now imagine you need to make one tiny change to that formula. You'd have to hunt down every single copy and fix it. I mean, it is a total nightmare waiting to happen. But on the right, that's the smart way. A single, clean, reusable function. That's it. And we're going to see exactly how to get from that mess on the left to the magic on the right.
And this mess of copy-pasted code, it's more than just ugly. It's a classic sign that things are inefficient. Look, your script might work, for now, but it's getting harder and harder to read, it's a real pain to fix, and it's almost impossible to update without breaking something by accident.
So, have you ever found yourself in that trap? You're copying, pasting, and you just know there has to be a better way. Well, you're absolutely right, there is.
And let me introduce you to that better way, the Python function. The easiest way to think about it is like a mini program that lives inside your main program. It's like a specialized tool that you build just one time, and then you can use it again and again and again whenever you need it.
So what is it really? At its heart, a function is just a named, reusable block of code that does one specific thing. It's like giving a name to a whole set of instructions, right? Instead of rewriting the entire recipe every single time you want to make cookies, you just tell the kitchen, make cookies. That name, that function, holds all the power. And you know what? Building one is actually super simple. First, you kick things off with the keyword def. That just tells Python, hey, heads up, I'm defining a function. Then you give it a clear descriptive name, something like calculate_BMI. Right after the name, you add a pair of parentheses. And finally, all the code that belongs to that function gets indented right underneath. And that's pretty much it.
Okay, so a function that does the exact same thing every single time, that's useful, sure. But the real power, the real magic, happens when a function can adapt, when it can take in different information and give you back different results. This is where we start talking about giving our functions inputs and getting outputs back.
Which, of course, leads to the big question, right? How do we actually get our data, a specific person's height and weight, into our shiny new calculate BMI function? Well, we do it with something called parameters. These are basically special variables that you set up inside those parentheses when you first create the function. They act like little placeholders, just waiting for the actual data you'll give it later. So for our BMI example, height and weight are our parameters, ready and waiting to receive some values. All right, check this out. When we actually use the function, we give it that data as arguments. On the left, you've got positional arguments. Python just kind of guesses. Okay, first number's for height, second one's for weight. It works, but man, is it easy to mix those up. But look at the right side. These are keyword arguments. Here, we spell it out. Weight equals 70, height equals 1.75. All of a sudden, the order doesn't matter, and our code is so much easier to read. And hey, speaking of making things easier, Python has another awesome trick up its sleeve: default values. You can set a default for a parameter right when you define the function, like unit equals metric. This means if you don't bother to specify the unit when you call the function, it'll just automatically use metric. It's a simple way to make your functions even friendlier to use. All right, so we've got data going in. Awesome. But how does our function give us an answer back? Well, that is the job of the return statement. Once your function is done with its work, the return keyword is what sends the final result back out to your main program. So, just imagine you have a function that converts Celsius to Fahrenheit. You pop in a number in Celsius, it does its little calculation inside, and then it uses return to hand that final Fahrenheit temperature right back to you. The function does the work and gives you the one thing you needed: clean, simple, perfect. So once you get the hang of this, you're going to start writing a ton of these awesome, useful functions. And the next logical step is to get them organized so you can use them in all your different projects, right? That is where modules come into play. Seriously, the best way to think about a module is like a toolbox. It's just a Python file. Maybe you call it mycooltools.py or something, and you fill it with all the amazing tools, all the functions that you've built. Then whenever you start a new project, you just import your toolbox, and all your custom-built tools are ready to go. And here's the best part. This whole toolbox idea is so powerful that Python comes with a giant workshop full of them already built for you.
You can import the math module and instantly get powerful tools like SQRT for finding a square root, or import the random module to get tools like choice for picking a random item from a list. You don't have to build everything from scratch. A whole world of tools is just waiting for you.
Okay, so we've covered the what and the how, but let's take a step back and really lock in the most important part, the why. Why should you really truly care about all of this?
Oh, the benefits are absolutely huge, and they change everything about how you code. First, you get to live by the golden rule of programming, DRI, or don't repeat yourself. You just write way less code. Second, your code becomes 1,000 times easier to read. It's all organized into logical blocks with clear names. Third, fixing bugs becomes a piece of cake. You just update the logic in that one function and it's fixed everywhere. And finally, your code becomes reusable. You can take that amazing toolbox you built with you to your next big project.
You know, there's this fantastic quote from the computer science legend Edsger Dijkstra that just nails it. The art of programming is the art of organizing complexity. And that's exactly what functions let you do. They are your #1 tool for taming chaos and creating beautiful, effective code.
So there you have it. You now have the tools to go from that tangled, repetitive mess to writing clean, modular, and, dare I say, magical code. You get not just how to build functions, but why they are the foundation of good programming. So the only question left is, what amazing thing are you going to build first?